talk now.
Okay, sir.
Good morning.
Hamida ma'am, shall I start?
Yes, ma'am, please.
Very good morning to all my dear participants. Today we have with us Dr. Sunil Kumar Goyal, Assistant Professor from Department of Agriculture Engineering, Banaras Hindu University. Dr. Goyal did his BTech in Agriculture Engineering from Chandrasekhar Azad University, Kanpur, MTech in the same discipline with specialization in Agriculture Processing and Food Engineering from IJE Raipur, and completed his PhD in Agriculture Process and Food Engineering from Sardar Vallabhbhai Patel University, Meerut. He has also been awarded a postdoc fellowship by UGC for conducting his research on various qualities of basmati and non-basmati rice. Dr. Goyal is a recipient of 2 national awards: Rajiv Gandhi National Award in 2013 for book authorship by Honorable President of India, Sri Pranab Mukherjee ji, and second one is Rajbhasha Gaurav National Award in 2015 for book authorship by Honorable President of India, Sri Ram Nath Kovind ji. Dr. Goyal has also been conferred more than 19 awards like Young Fellow Award, Best Extension Award, Innovative Scientist Award, Award of Excellence for Energy Awareness in Agriculture, Best Editor Awards, Young Scientist Award, Global Outreach Awards, and many more awards. He has organized about 7 national and international seminars, and he has delivered more than 55 invited talks. He has published 23 books in Hindi and English, 19 book chapters, 61 research papers, review papers, and more than 250 popular articles. He has guided 8 PhD and PG students of food science and technology, dairy technology, and food technology. He has handled 8 research projects funded by various agencies like DST, ICR, UGC. Okay, with this word, sir, I would like to invite you, sir, and thank you, sir, for accepting our invitation. Yes, sir. Over to you, sir.
Thank you so much, Dr. Anuradha ji, for telling about my academic careers and about me. So thank you again. I also thankful to organizers, Dr. Jadon sir, Dr. Sonam, and Ms. Khanam from Jammu and Kashmir, NADCL. So friends, really this is a great opportunity for me to interact with you all intellectuals. Actually, there is a small glitch. Actually, my lecture was scheduled for today at 2:30 to 3:30, but due to some you can say airlines problem, I am in ETM University, Visakhapatnam. I am here for attending a DST group meeting, and I'm handling a DST project. So I'm here. That's why my lecture is preponed for this time. So I'm thankful for all organizing members of this event for arranging my lecture from afternoon to this session. So thank you again. Friends, as we know that our economy is our country, and we are at the top position for the milk production. We have a huge number of cattle, bovines, and many other things. Those are a very, you can say, important factor for the milk production. So today I will be discussing about recent advances in feed processing for better milk production. As Dr. Anuradha is telling about my career and about me. So I am Dr. S.K. Goyal, working as assistant professor in the Department of Agricultural Engineering. In BHU, this department is known as farm engineering. Okay, and my specialization in agricultural processing and food engineering. So I will be discussing about some techniques about this feed processing, how we can process feed for the better consumption of the cattle and other animals. So in this, I will be discussing about animal feed technology. What is the history of feed technology? and what development has been passed in our India regarding feed technology, and there is a specific objectives regarding this feed technology. Then I will also be covering by types of meals and mixtures. Those are you can say important machines. Those are covering by the animal feed processing technology. Then a special, I can say, technology that is known as pelletizing, I will also be covering. Then forage processing, and at the last take-home message means conclusion of my talk. So, as I told you, India ranks first in the milk production globally, and near about 25% of global milk production was provided by our country during 21 to 22. And the milk production of India has registered near about 60%, or you can say 58% increase during the last 9 years, because there number of changes are happening in our dairy industry, including feed technology, milking technology, and many other type of advanced technologies are covering by the dairy technology. That's why this 58% a huge increase has been recorded during our last 9 years. Okay, and during the year 14-15 and 22-23, it increased about 230 billion tons in the year of 2030. So this is a you can say important data, which is the base of our today's lecture. So let's start. What is AFT? AFT means animal feed technology. So we can define this AFT as the application of physical, chemical, biochemical, biological, and engineering techniques to enhance the nutrient utilization. This is a, you can underline this thing, nutrient utilization of feeds and fodder in animal system, means livestock and other things, improving the health and productivity of livestock. When we supply a good feed to the animals, then definitely the health of that animal will be better, and only a healthy animal or cattle can give you a better milk production. Okay. So feed is the largest single item of expenditure in the animal production. This is a also an important thing. When we are talking about inputs of any production system, and when we are dealing with the livestock and cattle or any productive animals, here we are talking about milk production. So feed is also a very you can say largest single item to expenditure. We or dairy owners are expending a huge amount for the feed of their animals. There is a challenge of feed industry is to formulate, manufacture, and distribute feed to farmers that enable quality production. Presently, you all are knowing or aware about, there are two systems are working in our country. One is production, second one is quality production. In each system, you can think about food, think about dairy industry, think about any other production system. There are two systems, production and quality system. So when we are talking about better milk production, then we have to take care of all activities those are responsible for quality milk production, or you can say better quality milk production. Okay. So this is a great challenge to our dairy industry. Then if we discussing about feed technology, then there are some requirements for that, like knowledge of nutritional requirements of various livestock. As you know, there are means different cattle or different livestock having different nutritional requirements. So when we are going to formulate you can say feed, then first one should know the what is the nutritional requirement of particular livestock for whom we are going to process the feed. Second one is quality control of feed ingredients. It is also an important factor. Then feed plant management. Feed plant management means there is a number of lines, or you can say number of machines are installed for feed processing industry. So there should be a proper plant management. Without proper plant management, you can process the feed, but that cannot be covered by the quality feed production. Okay. Then at the last, storage of feed ingredients and feeds. Our storage system should be very, you can say, hygienic and safe for storage of processed feed items. Okay. Now, if we are discussing about history of feed technology, then mills were first built for grinding wheat and maize for human consumption, that for livestock. In ancient time, generally the grains or other consumable items are grind with the simple chakki, between two stone parts. Okay? So after some time, when the technology is geared up to the advancement, then these mills are using for the grinding of maize especially. And waste material were dumped into the river at that time. So that waste material may be converted as a nutritional food with using some advanced technologies. Okay? And chemical analysis gave good result, hence got market value. But there was variability in cost of product and quality of product, which led to information of AAFCO, that is Association of American Feed Control Organization, which defines more than 230 different ingredients acceptable for sale in the 1969 in US. Okay. Then urea was accepted in 1930s due to shortage of protein due to war. So urea, and at that time, urea is using as a, you can say, as an important ingredient for this feed system. As I told you, these the definition. Okay. The subject of feed technology, which we are discussing about present time, deals with processing of feeds, powders, and preparation of formula feeds. Okay. As you all know, formula feeds means there are some specific requirement for any particular animal or any particular breed. So when we are preparing some specific type of feed, that is known as formula feed, for which the knowledge of nutritional requirement of various livestock and poultry, I am just talking about all about the animal types. Okay? And quality control of feed ingredients, feed plant management, and the storage of feed ingredients and feeds are essential. So these all words can create a definition of feed processing. Okay. Then there are few facts about beginning of feed industry and related activities in US, and I will be also discussing about in our country. In 1987, Mr. John Barwell initiated the production of calf meal at Batchford of Waukegan, Illinois. At that time, he started that thing. Then American Feed Manufacturing Association, AFMA, was founded in 1909 in Washington, and its name was changed to American Feed Industry Association, AFIA, in 1985. So there are some types of changes were happened at that time since 1909 to 1985, and they changed the name of that organization. The Association of American Feed Control Officials, AAFCO, was established in 1909 at that time. And the linear programming mathematical procedure was developed by George B. Densing in 1947 for the preparation of this feed. And Mr. Wag of USDA was the first to see the potential of this mathematical procedure and develop a least cost dairy feed in 1951. So I am just giving you the simple facts in a bullet form.
Dr. Sunil sir, you are not audible.
Yes, answers to any food except where required. Is there any problem?
No, sir. Now it is okay, sir.
Okay, thank you. And feed production school was established in 1950 in US. You imagine when in our country we are not aware about agricultural production. In our country, the first agricultural university was established in 1960s at Pantnagar, near about the Green Revolution time. At the you can say before 10 years ago, in US they established feed production school for the you can say educated the pupils regarding this feed industry. So there are some AAFO definitions. I am not going to read out. That there are different types of feeds are available, like complete feed, concentrate, premix. You all are aware regarding these things. Now I am discussing about development of feed industry in India. Later I was discussing about beginning or development of feed industry in US. Now I am talking about in India. So the first feed mill established in India in Ludhiana after establishment of our first Indian Agricultural University at Pantnagar, that is established in 1960. After 1 year of establishment of that university in Ludhiana, we established, or Indian system established, first feed mill that is totally, you can say, responsible for feed production. Okay. During early times, there were many constants, like, because when we are going to start any new thing, then there are number of problems or challenges are facing by the, you can say, person who is looking at all the matters. So there are also a number of challenges like high cost of ingredients, because during that period, means during that 60s, nobody is think about feed system. So when the system had started during 1961, so the ingredients cost were very high. And second major challenges was non-availability of that ingredients, then low productivity of that ingredients, or when this system or this mill is start, then the productivity was very low. And fourth one was ignorance. Actually, people were not aware about the feed technology, and not only technology, not about the feed. Just they feel animal or livestock can feed by only these your green fodder, your husk and straw. They at that time they only think about these are the feed system and animals can feed by these only. Then lack of legal controls. This is also a major problem. Then on 8th June 1967 in India, CLFMA, means Compound Livestock Feed Manufacturer Association, was established on 8th June 1967. After that, some, you can say, a smooth run or smoothly this system is running in our country. Okay. So after that, it is recognized by central and state both governments, this CLFMA. Okay. And it views all considered while formulating and implementing policies concerning food industry. So this CLFMA was dealing with related to the feed industry policies with state as well as central government. Okay. And it also published feed trends, a quarterly magazine. So these are few facts regarding the development of feed industry in our country. Okay. So at that time, CLFMA has different types of activities. As I am discussing, like it is recognized by the central and state both governments. It conducts symposium on feed-related problems and discuss them. It organizes orientation courses at veterinary colleges for the benefit of the students, because at that time, the syllabus of BBSC or MBSC, there is a lacking of courses related to feed technology. So for that, you can say the bridging the gap of that feed technology, they started to organize orientation courses for the students. And it represents the problem of feed industry to government, like import duty rates, excise duty, and many other things. And it all, as I told you, it published Feed Trends Quarterly magazine, and it constituted awards to honor the nutritionists who contributed substantially to the present day knowledge. So it is also a very important matter, because when a pupil is group of people or single pupil, man or woman is working on the nutritional field, or you can say feed industry field. So if that person or group, if awarded or recognized by this or any organization, so that is a very important thing for encouragement of that group of that person. Now, there are some specific objective of food technology, because without objective we can go to reach our destination. For that, there are certain objectives like to increase digestibility and utilization of our feed, to improve content of nutrients, because as I told you, first I have to know for whom we are producing or developing the feed with the use of different types of technologies. So if we are keeping this objective in our mind, then we can successfully to reach our destination for the feed technology regarding of this thing. To improve amount of feed consumed and destroy pathogens, toxins, and weeds, and improve storage life and prevent oxidation and destruction of nutrients. So these are few important objectives. Allow proper mixing, improve feed order, and easy transportation. So these are few important objectives. Those are directly related to the recent advances of feed technology for better production of any type of animal. Now, processing of feed and forages. So there are different advanced technologies are available for the processing of feed and forages. So first I am discussing about primary processing technologies, like to make more profit. Anyone is doing any business for what? To earn some, you can say, bread and butter at initial level, and after that, that organization or person is doing that work for earn more profit or earn the money, or you earn the benefit, you can say. Okay. So, and the second one is to alter particle size. As you know, the raw material is of different particle size, means maize is a bigger size. Okay. Then barley and other feed raw material having different sizes. If we can alter, means reduce the size of that particular raw material as a feed, then definitely it will be beneficial to the our animals, because these reduced particle size is easily to digest, and they enhance the digestibility of that particular material. So the example of grinding of any raw material means maize, wheat, your gram, barley, whatever you are giving as a feed item in a ration to the animals. If you grind that, then it will enhance the digestibility of that particular material. And next one is to change moisture content. Moisture content is you can say center point. Moisture content is important for, you can say, processing of any feed material or storage of processed material, because if a particular moisture content is required for particular machine for particular raw material or ingredients. For example, if you are processing or reducing the size of maize. At that time, that maize have being a specific moisture content. Below or upper, you can say extra and below moisture content may be harmful for the particular that machine, or if you forcefully process that maize, it means you are the electricity consumption may be high for that particular extra moisture content that maize or any feed stuff having. Okay. The next one is to change the density of feed. Actually, as you know, raw material, or you can say raw feed stuff having a low density, and when we process when we are going through these primary processing of that feed stuff, then the density may be increased. And this is important for the storage purpose also. To change the palatability, as I told you, if you grind it and you add some molasses or flavor and fats and other things as a, you can say, ingredients, then the palatability definitely will be high. And next one is to increase nutrient availability, like starch 7 to 8% of dry matter, and protein appears to less available in jowar than other grains, but new processing techniques produce dramatic improvement in the feeding value of jowar. As I told you, if you add some other ingredients to enhance the palatability, to enhance the digestibility, as well as to enhance the nutrient availability, then it is also a primary. This is also a system, or you can say unit operation for the primary processing of feed stuff. And pelleting of feeds increase the utilization of phosphorus for chicken and pigs. So these are other things to detoxify or remove undesirable ingredients from the feed stuff. And at the last, to improve keeping quality. As I told you, high moisture grains may be preserved by either drying or chemical treatment. Means for good keeping quality, you have to reduce your moisture content of that feed stuff. So this is also an important thing, important point for the primary processing of feed. Now, when we are talking about size reduction or reduce the particle size, for that there are different techniques. Technical terms are using for the different machines. Okay, like cutting, chopping of green fodder, straw, hay, and other. Then next one is crushing. Next is searing. Next is impact grinding. So these are technical terms. Those are involved in, you can say these are principles. Those are, the machines are based on these principles, like hammer mill, like burr mill, like other mills. Okay. So there are various treatment methods are also useful in our feed industry, like physical method. Physical methods means soaking, grinding, pelleting, extrusion, steam under pressure, and irradiation. So these all, you can say, unit operations, or you can say treatments are important for feed processing industry, and these all treatments came under physical methods. Okay, there are another chemical methods like use of NaOH, anhydrous and aqueous, and NH4. Then another H2O2 and urea ammonia treatment of crop residues. When we are dealing with crop residues, and that crop residues is using for a raw material for the feed industry, then these chemical methods are applicable for the better production of our feed. Okay. Then at the last, biological methods, use of certain microorganisms that are very efficient for lignin breakdown, but with slow degradation rate of cellulose and hemicellulose. So for that, generally biological methods are applying for this feed industry. They told you sharing impact jet mills. So for impact grinding, generally jet mills are using. In jet mills, the material to be reduced is carried in air or gas through a nozzle against an impact plate. So the impact produces fine particles. Okay, so this is the principle. You can say this is the real technique by which the particles is reduced in a fine particles. Okay, the velocity of jet usually corresponds to hammer mill peripheral speed like 27,000 to 36,000 feet per minute. This is the speed of that jet mill. Okay? And the efficiency of that jet mill would depends on the velocity of the air or gas stream, the velocity of the material being reduced, and the quality and conformation of impact surfaces. So these are few points. Those are responsible for efficiency of the particular jet mill. Okay? Then another thing is centrifugal input mill. Okay, I'm not going to discuss all these things. Okay? Various steps involved in feed compounding. There is a terms that is known as feed compounding. Okay? For that, there are certain steps. So we have to follow these all steps for the feed compounding, like selection of locally available ingredients based on price and nutrient density. Okay? So if we are going for the feed compounding, then we have to choose locally available ingredients. Okay? Because the price of that locally available feed ingredients may be less and the nutritional may be high in that local ingredients. Okay? Then quality check of raw material, because raw material is the base of your final product. If the quality of that raw material is not up to the mark, then your final product may be of not maybe a good quality. So it is essential to check the quality of that raw material at the initial point. Okay, for compounding of feed. Then formulation of balanced ration. If you are going for the formulation of balanced ration, then you have to identify and calculate all the your ingredients and which quantity or what ratio is applicable for the optimum ratio is applicable for the formulation of that ration. Okay? Then weighing of the ingredients, processing such as grinding, mixing and other things, and quality check of processed feed. Here again you have to check the quality of processed feed or the final product. Okay? And after that, packaging and storage of mashed feed. So this is, you can say, the last step, packaging and storage. But after that, you have to transport these processed products to the other industry or the market. So further processing for preparation of other forms of feed like pelleting, crumbling, and other things. So these are few steps. Those are important for feed compounding. Receiving of raw material, I am not going to discussing that. Yeah. For the grinding, the first and important processing method in feed industry, this is known as grinding, and there are certain advantages. First, 1 minute. Okay, I have left 31 minutes. So there are some advantages of grinding in this feed industry, like the particle size reduction increase the surface area exposed to the enzyme, resulting in better digestion. When we reduce the size of any material, any raw material, which is using as a feed, then after reduction of the size of that particle, there are size specific your surface area of that particular raw material has increased, and this is directly exposed to the enzymes and it resulting in a better digestion. Okay? That's why the grinding is very important. Next one is grinding helps mixing of ingredients as it prevents segregation. Without grinding, we cannot mix the ingredients in a better way, and the final product may not be the good quality if we are using the raw material without grinding. Okay? Then pelleting can be done only if the feed is ground uniformly. If we are going for the pelleting, then without grinding of the particles with a uniform size, we cannot go the successful pelleting system. Okay. Then the selectivity of feed is not possible by the animal, and so the nutrient intake will be optimum. If we are not going to the grinding, then this selectivity of the food is not possible for a particular animal. Okay. Then palatability is improved after grinding. Then feed intake is increased if we provide our feed material as a in the ground form. Then improved digestibility, as I told you, the exposure area of for the enzymes has enhanced. So this result in a better digestibility. And if the digestibility of particular material, raw material, is good, so it is a can say positive indicator for growth rate of our animal. And it also improves feed efficiency, because when the feed ground, or if we supply the ground feed to the animals, then there are certain parameters by which the animals are taking that meat, or you can say fodder or feed, with interest. So the feed efficiency is also be enhanced. The grinding of some other ingredients contributes to ease of handling. Ground material may be easily handled with a high density, and they reduce the storage space and other things. So this is a simple grinder. You can say fixed mill. Then there are basically three mills are using in our feed industry. First one is hammer mill, and this is work on the impact of principle of impaction. Second one is attrition. This is based on cutting, crushing, and shearing method. And last one is roller mill. This is also covering by the cutting, crushing, and shearing principle. Okay. Now, hammer mill. What is the hammer mill? Hammer mills. This is the picture of a hammer mill. Okay. This is a enclosed chamber. Okay. And this is the cylinder. And the cylinder has a number of hammers. Hammers, all you know, hammer, thoda. So these number of hammers are placed inside the cylinder, and when it rotates, it converts the feed into fine particles with the impact of that hammers to the grain or feed. Okay. So these mills are used impact grinding principle, as I told you, to reduce the particle size of feed. Hammer mills are used for grinding of both concentrates and forages. For both purpose, we can use these hammer mills, and it has been used for farm, commercial, and custom grinding of many years. You can say this is the oldest one machine or mill which is using in our feed industry or for the grinding purpose. Okay. The hammer mill consists of a cylinder or rotor, as I told you, seeing you in my next slide. Okay. The outside the rotating cylinder is perforated steel screen. I am going to show the screen size or different types of screens is using in this mill. The hole in this screen may be as small as 1 by 32 inches or as large as 2 or more inches. Okay. The hammer mill tip may travel at a speed of 7,000 to 25,000 feet per minute. This is the speed of that hammer mill. Okay. A fan or blower is usually used for the product transport after grinding. Okay. So this is the picture. You can say that a hammer mill. These are the screen size. Different screens. Those are using for the feed processing for the different types of feed raw materials. You can say. Okay. So the size of these screens is 1 by 32 inches to 2 inches. Okay. So 1 by 32 inches maybe this one means smaller, and this or this may be as a 2 inch. So factors that affect the performance of hammer mills. There are a number of factors. Those are directly affect the performance of working of that hammer mill, like diameter and shape of the screen opening, as I shown you in this picture. Okay. So which type of screens size opening we are using? So we have to choose a optimum, you can say, correct size for the processing of your feed. Second one is screen area. Screen area means this screen area, the whole screen area. Okay. the whole size of that screen is known as screen area. Okay. So this is also responsible. Then moisture content, as I told you, if you processed high moisture content feed, it means your energy consumption, or you can say power requirement, may be high. Here it is reported that the power requirement in kilowatt hours per ton increased rapidly at higher moisture content. Yes, then kind of feed, we have to choose a good type of screen with respect to the type of your feed. So this is some different things. This is known as width of the screen. This is length over the back. Here you can say length of the screen. Okay, and this is perforation, means the opening of size. This is known as perforation, and the thickness of that seat or sieve is known as gauge. Okay. There are different types of gauges that are using for the that screens. Then roll outside dimension. This is known as roll outside dimension. So these are few technical you can say terms. Those are applicable or used for the calculation of the power requirement or fine your particle size calculation. Okay. Then hammer tip and screen clearance. Hammer tip and screen clearance means this is hammer tip. You can say this is hammer tip and this is screen. So the space between hammer tip and screen is known as screen clearance. Okay. Yes. Product is this shown to 8 mm. Okay. Number of hammers. How many hammers are using in your mill? So the size of that mill depends on the size of hammers. Number of hammers. Okay. Then mechanical condition of the mill, which type of mill is available, unknown screens and hammer mill. Their sharper corners are more efficient. So these are few. The last one is HP of the motor, means the size of the motor. Size of the motor is calculated in HP, horsepower. Okay. So which size of motor is applicable with means the compatibility of the electric motor should be with your that mill. The motor size should be matched with your hammer mill. Okay. So the production of hammer mill depends upon the different factors, as I am discussing earlier here in the bullets form, like horsepower means the power requirement, diameter and shape of screen opening, screen area, moisture content, peripheral speed, kind of grain means feed, location of feed intake, hammer tip and screen clearance, as I discussing you, the clearance between the hammer and the screen, number of hammers, how many hammers are inbuilt in your particular machine, then hammer width and design, air flow through the mill. So these all important factors, those are responsible for the better production of feed through the hammer mill. Okay, this is total view of that hammer mill. I am not discussing more because only 19 minutes I am having, or you can say remain for this talk. Next one is whir mill and attrition mill. This is the simplest machine or mill. This mill you can see the flour mill, generally the atta chakki, which is available in our locality, where we go through to the convert our grain to the flour. So that chakki, or you can say that mill, is known as attrition mill. Production and attrition mill is affected by. So there are few points, those are responsible or those are important for getting a good quality product by using this attrition mill, like speed of plates, rate of feed, design of plates, spacing of plates, and wear of plates. So these are few factors. Okay, this is the picture I am having. I am not having the line diagram, so that will be better for your better understanding. Then last one is roller mill. So these are used in feed processing for the crimping or crushing of the grain. So these all are the bar mill and your attrition or bar mill, and this roller mill. This is depends on the same principle. Okay? So this is crushing. The basic principle is crushing, cutting. Here is the cutting, shearing, and crushing. So this is the picture of roller mill. Okay, this is the real picture of roller mill. This is the line diagram by which you can easily understand. This is the feed unit. Here the raw material has fed. After that, this down by the gravity force, and it passes. You can control your feed through this roller mill, a roller. You can say roller feeder, and these are the first pair of rolls. Here, your feed is came into the contact of the first roller, and they reduce the size. Then, if you need this size of your feed, then you doesn't need to go for the second pair of rolls. If you need more fine particles, then you go with the second pair of rolls. Okay. After that, in the bottom, you can get the finally product. Okay. So there are also after that these mills we are using for the feed industry. We need to mix that material to formulate different types of our feed system, like feed mixing, hand mixing, and mechanical mixing. So feed mixing means mixing of the raw material. The process of uniform distribution of the different feed ingredients in the compound is known as feed mixing. Okay, simple. When we are using our hands to mix anything, so in the same manner, we did this work by the help of a mechanical method, with the help of machines, or we can do with the if we having a small amount, then we can do this work by our hands. Okay, so if we are going with the mechanical mixing method, there are two types of machines are available. First one is vertical batch mixer, and the second one is horizontal mixing. Okay, the first picture is showing the vertical batch mixer. Vertical batch mixer means this is the hopper. Here there is a screw conveyor type system. Here you feed your ingredients, and it mix and collect it into this chamber. You can say collection chamber. So this is known as vertical batch mixer, and this is a batch type machine. This is horizontal mixer. Horizontal mixer means here you can see there are helical type screws, and there are some you can say different types of plates, steel plates. Those are using for the mixing of that your ingredients. So particular these two types mixers are commercially using in our feed industry, in Indian, especially Indian feed industry. Okay? So there is a comparative analysis of that two mixtures, like vertical mixer and horizontal mixer. Here you can see the relative cost of vertical mixer is high, and they give a good job for drying mixing. Okay, and when we talking about horizontal mixer, it is expensive and do a good job for dry and liquid both. Okay, so you have to choose which type of ingredients you are going to mix, so that for that you can choose vertical or horizontal. Okay? Then use the vertical mixer is not used in larger feed mills, but the horizontal mixer used in small mill and the larger feed. This is applicable in both mills. Okay? Then flour space. So vertical mixer is using less space, and horizontal definitely it will use more space, floor space. Okay, the time it's take near about 20 minutes or less time, and it takes 3 to 5 minutes per batch. So this is a vertical mixer is slow, and the horizontal mixer is very fast, you can say. And the power requirement is in vertical mixer is less, and the horizontal mixer is more. Discharge rate of the vertical mixer is opening at the one place, and in horizontal mixer opening at several plates along the bottom to the head is a more discharge area. Okay? Then clean out lesser extent is in vertical mixer, and 100% generally in horizontal mixer. Okay? So liquid addition in vertical mixer, molasses fat can be mixed, but in horizontal it can be mixed efficiently in very good manner, and that the result is very better in this horizontal mixture. Then mixing efficiency is lower of this vertical mixture, and horizontal mixture is approaches near about 99%, and it is better than the vertical mixture. So one should choose which type of, well, one can choose a mixture based on their individual requirements. Then determination of feed mixing efficiency of a mixture production per hour. So there is a simple formula. Production per hour is equal to 60 into E into F divided by ABCD is equal to ton per hour. So what is ABCD? So there is a simple formula. A means filling or feed loading time in minutes. B is feed mixing time in minutes. And C is emptying time after mixing in minutes. D is dead time in minutes. Okay. E is the loading capacity of a mixture in tons. F is efficiency index depends on the use of mixture to its maximum capacity with maximum cycling time. So then the production of mixed feed per hour, that is 60 minutes, will be determined by the use of following equation. Okay, so this is a simple, you can say equation. This is simple formula, and the notations as I described you. If you are going to mix any ingredients and using any mixture, then you can simply calculate the feed mixing efficiency of any mixture. Okay. Now processing methods of grains. Now I am going little fast. For the processing of grains, we are using two types of processing methods. First one is drying processing method. Second one is wet processing method. In drying processing methods, generally grinding, dry rolling, popping, extrusion, micronizing, and roasting are the main processing methods for the drying purpose. And for wet purpose, generally we are using soaking, steam rolling, steam processing and flaking, pressure cooking, exploding, pelleting, and reconstitution. So these are a few important processing methods for both the dry and wet. I am not going to discuss each and every one because there is a very less time to me to explain each and everything. Okay, then pelleting of feed. Pelleting is an important thing for the important, you can say important operation or important unit operation for convert raw feed or mixture of feed to convert into a pelleting form. And pellet is very important thing to the animals also, because the processing of the densification of a single feed, concentrate mixture or complete feed in the cylindrical shape is known as pelleting, and the compressed or agglomerated feed thus produced is called pellet. Okay, it's simple. In the cold process, moisture and pressure are applied, whereas in hot process, the moisture is replaced by the live steam. So this is simple techniques. Okay. There are two types of pellets are available: hard pellets and soft pellets. Okay. Generally, bentonite, calcium oxide, or calcium carbonate may be required as a binder for soft pellet. For the soft pellet, as a binder, we can use these 3 or 4 types of binder system. In addition to these chemical compounds, starchy ingredients and molasses are the common binding agents. These are the common binding agents. Those are applicable for this pelletable pelleting system. Okay, so this is pelleting system. Here, first storage bin. Second one means I am just going giving you the flow diagram. Then storage bin. Then is the raw material goes to the pellet mill. After that, it goes to the cooler. After that, it goes to the crumber. Then elevating system. Then pellet scraper means screen, and the last steam supply. After following all these 7 steps, we can obtain a pellet. Okay. And there is a parts of pellet mill like feeder, conditioning chamber, pelleting device, speed reduction device, prime mover, and base. And generally 20 to 40 HP to 700 HP size of electric motors is using for the operation of this pelletizers. Okay. So this is a part of a pellet mill. Simple sketch diagram is here. Okay. So this is your feed. You can upload, or you can say fill the feed in this feeder. Then conditioning chamber. Second, that material is come to this conditioning chamber. After that, pelleting device. Here is the pelleting device. They produce the pellet. Then a speed reduction device. You can control the speed of pelleting production. And here the prime mover. This is the prime mover. This is using to the remove the pellets from this place. And sixth one is the base of that particular machine. Okay. So steps in the preparation of hard pellets. I'm not going to discuss more things. Then advantages of pelleting. It reduces wastage because we can also use the residuals or raw material, waste material or byproducts of your agro industry. It improves pelletability, increase the density of feed, less storage space is required when we convert our feed into pellet form. It is helpful to the transport, okay, and it increase the digestibility. It breaks the binding of the cellulose and lignin. So these are few important advantages. And then it can give the more uniform size. Okay, there is no selection on the part of animal health. Okay, and some waste material can also be incorporated efficiently. Means if you are having your byproduct of another crop residual, then you can use as an ingredient, and it can be converted into pellets. There are some, every coin has two faces. So same here is happening. There are few disadvantages like cost involved with many more because the initial cost is very high, and the non-availability of machinery and equipment means generally machines are available in our Indian market, but still if you are looking of better pelletizers, then you may you should pay a good amount for that particular machine. Okay, so this is the raw, you can say, flow diagram of that particular pelleting system. Then at the last, roughage processing methods. First, we process our grain, and for the roughage processing method, generally here we can also use two systems, dry and wet. For dry system, we should use baling, field chop, grinding, pelleting, cubing, and dehydration processing method. And for wet processing method, we should use green chopped and soaking. So these are two basic methods. Those are using in our roughage processing methods. Okay. Then grinding, as I discussed regarding grinding of our grains, here the forage can also be grind with the different types of techniques like feeding of ground roughage, reduce rumination and rumen retention time. Okay. When we supply the ground roughage to our animals, then it is easily digestible. Okay. Then dehydration, then pelleting of roughages, we can also convert that roughage into pellet form. Okay. Then method of improving the nutritive value of poor quality roughages. When we are talking about advanced technologies in feed processing, then definitely we have to think about these things like poor quality roughages can be enhanced by the physical methods, chemical methods, physicochemical methods, and biological methods. So for these physical methods, the whole classic figures are giving here, like soaking, chopping, grinding, pelleting, buffering, steam under pressure, and irradiation. And for chemical, alkali, ammonia, then acids, then salts, and gases and oxidizing agents can also be used for the improvement of the roughages. And for physicochemical methods, combination of physical and chemical treatments like NOH pelleting and NOH steam. And at the last, biological methods, generally we are using enzymes and the rot fungi and mushrooms for the betterment of this roughage processing. Okay. Then there are few physical treatments. Time is going fast. I'm not covering all these. So there are some advantages of chopping of roughages, like it avoid wastage, it facilitates feeding of roughage and concentrate together into the form of complete feed. So there are any other advantages. Then forage processing methods, as I told you, in a tabular form, means graphical form. So this is another system. Here you can use in chopping, grinding, shredding. Okay. Now at the last, my time is also passing. Take home message means conclusion of my talk. When we are talking about advances, recent advances in feed processing technology, then one should, there are a number of technologies that are available in our country, and globally there are different types of advanced technologies that are available. But when we are going to install a feed processing plant or feed processing industry, then first one should think about the local availability of particular feed, and for which type of animal we are going to produce the feed. Means you are going to you are processing the feed to the cattle, livestock, or poultry, or piggery, or doggery. So you think about, then you go with, after that you have to choose a optimum, or you can say correct line of machines that may be better, that may get a better result for your requirement. Okay. And the last, economic, cheaper, and suitable feed technologies like soaking, grinding, chopping, protected fat and protein, urea, your blocks, then your other blocks can easily be adopted by the livestock owners depending upon the locally available feed resources. So, mean to say, the technologies are available. You have to choose correct technology for your industry or for your entrepreneur. So thanks again. It's already 12. If there are any query, I am here.
Okay, thank you, Dr. Sunil, sir, for this nice and informative session. Now the session is open for the discussion. Any participants, if you have any query, please ask.
Hello, ma'am. Is I audible?
Yes, sir.
Yes.
Thank you, sir, for nice presentation. And also, I would like to express my sincere thanks to organizer for selecting this very good topic, not only interest of the participant,